Now let's discuss the transformations which result in stretches and compressions. And we'll start here with the vertical stretches and compressions. So if you have a function of the form a number, we're going to call that constant number lowercase a times a function, then that's going to result in a stretch or compression. It is a vertical stretch by a factor of a if a is larger than 1. It's going to be a vertical compression by a, looks like I'm going to need a bit more room, so let's go ahead and do that. Factor of a, so a vertical compression by a factor of a if a is between 0 and 1. So in this first example, 3 times f of x, this is a vertical. I suppose first let's identify what a is. A is equal to 3. So this is a vertical stretch by a factor of 3. And what that means is you're going to have to multiply every y value by 3 if you want to sketch the graph. So to sketch 3 times f of x, multiply all y values by 3. Now for the second one, a is equal to 2/3, which means a is between 0 and 1. 2/3 is between 0 and 1, which means we're not going to have a vertical stretch, but a vertical compression. So this is a vertical compression by a factor of 2/3. And what that means is that all y values are multiplied by 2/3. As the name suggests, that's going to result in a compression vertically of the graph. Now the reason why we are multiplying all the y values is very similar to the reasoning behind why we were adding and subtracting to the y value when we did shifts. We have outputs here. F of x is a y value, and we're multiplying the y value by a number. In the first example, 3. In the second example, we're multiplying by 2/3. Now you might have noticed that I only detailed what the stretch or compression is when a is between 0 and 1 or when a is bigger than 1. Well, what happens if a is negative? In that example, you get both a stretch or compression and a reflection. Here's a couple examples to illustrate what I mean by that. So in this first example, a is negative. It's negative 3/2. So 3/2 itself is bigger than 1, so that's going to result in a vertical stretch by a factor of 3/2. Remember, that means we're going to multiply all the y values by 3/2. Then the negative on the outside is going to result in a vertical reflection. And that vertical reflection will occur about, well, if we're moving vertically, we're going to have to cross the x-axis. And remember, to do that, you simply multiply all of the y values by -1. Maybe it's worth mentioning as well that this is a stretch because 3/2 is larger than 1. And something very similar happens with -2/3 times f of x. You get a vertical compression by a factor of 2/3. And then you get a vertical reflection. About the x-axis. Finally, I think it's worth mentioning that you can change the order of these transformations without any effect on the graph. So if you do the vertical reflection first and then the vertical stretch, you'll end up with the same answer as if you did the vertical stretch, then the vertical reflection. Now that we've introduced the vertical stretches and compressions, let's introduce the horizontal ones. So horizontal stretches and compressions will happen when you have f of a constant times x in the parentheses. Remember, when something gets changed inside the parentheses, then horizontal transformations happen. When it's outside the parentheses, vertical transformations will happen. Now, in the same way that the horizontal shifts were counterintuitive, so are the horizontal stretches and compressions. So when b is greater than 1, we do not get what you would expect. I would expect that it would be a stretch, but it's actually a compression, a horizontal compression by a factor of 1 over b. So what this means is all x values are multiplied by 1 over b. So let's take a look at this first example here. So I have f of 3/2 x. In this case, b is equal to 3/2. Now notice that that's bigger than 1, and so this will be a horizontal compression and the horizontal compression will be by a factor of 1 divided by b. So by a factor of not b, not 3/2, but 1 divided by b, which would be 1 divided by 3/2. And 1 divided by 3/2 is 2/3. To divide by a fraction, you multiply by the reciprocal of the denominator. Now, if b is between 0 and 1, then what you get is a horizontal stretch by a factor of 1 over b. So all of the x values are going to get multiplied by 1 over b. So for example, f of 3/4 x. Well, b here is 3/4, and that's between 0 and 1. So this is going to be a horizontal stretch by a factor of 1 divided by b, 1 divided by 3/4, that is 4/3. And so the result is you're going to get a stretch by a factor of 4/3, particularly a horizontal stretch by a factor of 4/3. So this is unexpected, I would say, but what you can do to make sure you don't make any errors is carefully identify what b is. So in this first example, b is 3/2. Then remember that instead of multiplying all the x values by b, in both cases, whether it's a compression or a stretch, you're going to be multiplying by 1 divided by b. If b itself is larger than 1, then it's going to be a compression. And if b is between 0 and 1, it's going to result in a stretch. Also, similarly to the vertical stretches and compressions, if there is a negative sign, then you're also going to have a reflection. So for example, if you have f of negative 1/4 x, then this here would be b. b equals 1/4. So b is between 0 and 1. That's going to result in a stretch. So we have a horizontal stretch by a factor of 1 over b, so 1 divided by 1/4, which is 4. And then we're going to have a horizontal reflection and if you're reflecting horizontally, that's going to be about the y-axis, so about the y-axis. And again, it doesn't matter if you do the stretch or the reflection first. You get the same graph.